Hey guys, we're back with the notes for 3.4. That's going to be graphing when we're in standard form. Go ahead, pause the video, write what you see. Alright, let's go ahead and start talking about why we do this topic. So first of all, we learn to graph when it says y equals mx plus b. But obviously not every equation is going to be beautiful and set up ideally to graph. So we need to make sure that we understand how we can rewrite an equation or how we can use intercepts to help us get the graph even when it's not in slope-intercept form, okay? So I want to talk about intercepts first. Intercepts are one of my favorite topics because they're so easy and there's not really that much work. So I'm going to do the long way on the first page, and then when we go through the practice problems, I'll actually show you how to do these with no work, okay? All right, so let's talk about intercepts first of all. When you are thinking about an intercept, that means where is the graph going to cross the x-axis and where is it going to cross the y-axis, okay? So if I'm on the x-axis, like 4, 0, that means my x is 4, but my y is 0. If I'm on the y-axis, like 5, that means I'm 0, 5. My x is 0, my y is 5. So if I could use the zeros to figure out where I'm going to graph, then I would be able to connect the line from those two dots, okay? So let's go ahead and look at that first problem, and I'm going to show you what I mean by that. Okay, so to find an x-intercept, it basically means that we want our y to be 0. So if I make the 0 go where the y is, what's 5 times y? Sorry, 5 times 0. Good, that's going to be 0. What's 3x plus 0? Hopefully you still said 3x. So I'm going to set this up and show you what we're really doing. You don't have to write all of this, just watch for a second, I'll tell you what to write. Okay? If we were plugging this whole thing in, we would say, what is x when y is 0? But really, 5 times 0, like you said, is 0. 3x plus 0 is just 3x, so this is the equation that we're working with. I can solve for x in one step. I can divide both sides by 3, and that gives me -5. In other words, my point on the x-axis is going to be -5, 0. Okay? That's the long way to figure it out. I'm going to show you how to do this with no work. Okay? If I'm solving for x, that really means that I don't need the y. If I was to ask myself, how would I get x alone? In my mind, I can do -15 divided by 3 and go straight to my answer of that -5. Okay? That is what I'm fine with you doing on the practice problems. I'll show you what that looks like when we get there. Let's talk about the y-intercept for a second. Woo. On the y-intercept, I'm trying to find a y value. So obviously I'm going to plug in 0 for x. If I plug in 0, what's 3 times 0? Good, hopefully you said 0. What is 0 plus 5y? Hopefully you said 5y. So if I could get rid of this number, all I would need to solve is what is 5y equals -15. I would divide by 5 on both sides and get my -3. That means my point was 0 for the x and -3 for the y. That's what intercepts look like. They don't need that much work all the time, but that's what final points you should have, is something about x equaling -5 and the y equaling -3. Here's how it looks on a graph. We're going to take our x-intercept, -5, and we're going to put that point on the x-axis. Okay, so that guy is right here. We're going to take our -3 on the y-axis and put our point there. That's this guy. Then with our line, all we need are those two dots. Make sure you put the arrows on the ends, but that is your graph using intercepts. Okay? So we cover up one letter, solve for the other one. That's your point. Cover up the other letter, solve for it. That's your second point. Okay? Let's do a couple questions of intercepts. Okay, so we're going to scroll in through the paper. Go ahead and flip the page into your notes. All right, so if I go ahead and I set up problem number 1, there's 2 ways to solve it. We hope that intercepts work for everything. I'm going to show you what happens if it doesn't. Okay, So problem 1, here's how I check. Can I do 6 divided by 2? Yes. Can I do 6 divided by this ninja one? Yes. That's going to be intercepts, okay? Because I can divide it by both numbers. When I get to problem 2, can I do 12 divided by -3? Yes. Can I do 12 divided by 9? No. So on this problem, we're going to go ahead and circle it and say, I'm going to have to rewrite this because 12 doesn't divide by 9. Okay. Good news is we're only going to do the intercepts first. Okay. Let's go ahead and make the bottom decisions. So on number 3, does 4 divide by 2? Yes. Does 4 divide by 6? No. So I'm going to do a rewrite, and that's because I can't do 4 divided by 6. Let's try number 4. Can I do 10 divided by 5? Yes. Can I do 10 divided by 6? No. So on that problem, I'm going to rewrite again. 10's not divisible by 6. I'm going to have to rewrite. We don't know what rewrite is yet. I'm going to show you. Okay? But that's the check for intercepts. Let's try number 1. Let's go through this full problem then. Okay, problem 1. If I'm doing intercepts, here's what I want to see from you. I want to see you in your work, in your book, crossing off the letter you don't want. 2x equals 6. So what are you dividing? You're dividing 6 by 2. By 2. What is 6 divided by 2? Hopefully you're saying 3. So that means my x-intercept point is 3. That's this point on the x-axis. That's enough work for me to take, okay? All right, so for the second one, if I want to cover up and solve for y, I need to cover up the x. So if I say 6 divided by this ninja one, my answer would be 6. So that is my y. Y is 6. Well, I'm going to put that point on my y-axis right here, and now I can draw my line. Okay, that is your graph for problem 1. We're going to skip 2, 3, 4, and let's go to the next page. Okay, remember we're checking for intercepts first. So can I use 5 with intercepts? Yes. 16 is divisible by 4, and it's divisible by 8. That's intercepts. Can I use intercepts on 6? Yes. 6 divided by 2, 6 divided by 3, both of those come out as whole numbers. So yes, that's intercepts. Okay, let's go ahead and do 5 and 6. So we're going to set up my x-intercepts and my y-intercept. Who am I dividing on problem 5? Hopefully for the x's, you remember we're crossing off the y, and we're doing -16 divided by -8. That means my x is 2. What would we divide for our y's? That means we need to cross off the x. Make sure you don't take out the negative next to the 4. That goes with the 4. Okay? And for the y's, we're going to do -16 divided by -4. That means that our y value is 4. Okay? So if x is 2 and y is 4, then this is our graph. Okay? Let's try one more of these. Let's try number 6. So on number 6, if we want the x-intercept, that means we get rid of our y's. We're going to try and solve for x, so we're doing -6 divided by 3. That gives me -2 as my x point. What about my y? Who do I cover up? Covering up our x. Make sure you only cover up the x, not the -2. All right, and how would we get y? We would take -6 divided by -2, and my y answer would be 3. So my y dot goes on 3 on the y-axis. And now I have enough information to draw my line. Okay? All right, hopefully you feel like you got enough examples of intercepts to know how to check to see if you can use it and to complete those examples. Okay? Let's go back to the first page and let's talk about rewrites. Okay. For rewrites, we did a lot of this back in 1.3. So if you need more practice or you need to see what we're doing, that would be the place to look, 1.3 video notes. Okay. Our goal right now is that we are going to solve it for y equals. We want to get y by itself. So to do that, that means I have to kick people out of the party. B's the best friend, so B stays. I'm going to move ax to the other side by subtracting it, and then I'm going to divide by b. Okay, but this time the division is going to look a little bit different. We're going to divide it in 3 places. So let's go through that. All right, so for this first problem, I'm trying to solve for y. So I'm going to subtract 3x from both sides. I'm going to cancel the doubles and write what I see. I have negative 15 minus 3x. Okay, I can't put them together. 15 doesn't have an x. Then I'm going to divide by 5, but this time, when I divide, I need m and b to be separate. I don't want one big fraction. So I'm going to divide it 3 separate places. Okay? And then here's what's going to happen. I'm going to cancel out those, and I'm going to keep my y equals. But I want the mx to be in front, and then I want my b. So who's with the x? That's the negative 3 over 5. We want the fraction, or the slope, to be first. What about my b? What's my constant number by itself? Well, negative 15 divided by 5 makes a negative 3. This is my new equation. Okay, so yes, I did switch the order, and yes, I simplified the fractions. I simplified the yellow. Okay, so right now my m is negative 3/5. That's down 3, right 5. And my b is negative 3. So if I graph that, this would be old school. Begin at negative 3, go down 3, right 5. Going backwards, I would go up 3 and left 5. Notice that these are the exact same graph as what's on the page next to it. Okay, 2 different ways to solve it. But rewriting is what's going to work if our division for intercepts doesn't come out to a whole number. Okay, so if you have all that written down, go ahead and meet me on the next page. Let's talk about number 2. We said we couldn't do intercepts because 12 wasn't divisible by 9. So let's work it out. I need to move my x's to the other side by subtracting them. Write what I see. So minus 3y equals 12 minus 9x. I can't put them together. 12 doesn't have an x. I'm going to divide everybody by that negative 3 to cancel it off. Now, I have y equals, but I want to make sure that I put my mx first and I put my b second. Okay? So on this problem, my mx is the blue. Negative 9 divided by negative 3 makes a positive 3x. 12 divided by negative 3 makes a negative 4. So on this graph, I'm going to begin at negative 4, and I'm moving 3 over 1. Okay, so begin at negative 4, rise 3, run 1. This is my graph for problem 2. Okay, pause it if you need to, otherwise we're moving to number 3. Problem 3, we needed to rewrite because 4 wasn't divisible by 6, okay? So we need to move the 6x. We do that by adding this time, and that's because it's negative. We wouldn't subtract a negative. That wouldn't cancel. All right, so if I write what I see, I have 4 plus 6x. We need to get rid of the 2, so we're going to divide everybody by 2. It is not in the right order right now, so we want to make sure that we switch our m and b. That means 6 divided by 2 is 3. That's our mx. 4 divided by 2 is a positive 2. That's our b. So I'm going to begin at 2, and I'm going to move 3 over 1. Begin at 2, rise 3, run 1, all the way across my graph. This is your graph for number 3. If you need to listen to that again, maybe once to write it, once to actually listen, that would be a good idea. Okay. Last one, problem 4. We needed to rewrite it because 10 is not divisible by 6. So we're going to get rid of the 6. Subtract 6x from both sides. 10 and 6 does not go together because 10 does not have an x. So negative 10 minus 6x. We're going to divide everybody by 5. And then we're going to make sure that we put them in the right order. mx goes first, b goes second. So my mx, negative 6 doesn't divide by 5. We're going to leave it as a fraction. But negative 10 does divide by 5. That's a negative 2. So on this problem, we need to begin at negative 2 on the y-axis. And our slope is negative 6 over 5. Make sure you know that means down 6, right 5. Let's see, that one's kind of weird. How do we go down 6? 1, 2, 3, 4, 5, 6, I guess, and 5 to the right. That would be over here. How would we go backwards? Well, we could go up 6. So 1, 2, 3, 4, 5, 6, and left 5. 4, 5. Make sure it is still going downhill, and make sure you know that that is a negative slope. Okay. All right, if you need a deposit, get any more information, it is there for you. Otherwise, you should have enough information to make the decision, rewrite or intercept, and complete both. If you have any questions, feel free to come talk to me. Otherwise, get started on 3.4 practice.